Yes. So I'm just gonna make a video because I forgot that guy's name. One of the dudes was asking me if I could provide some insight on this, so I'm just gonna make some commentary on it. Um, Basically, in the hex editor, we're trying to figure out where the geometry is, so that we can do what we want to do with it, be to import it or export it. Okay. Clearly, the more you know about the file, the better. So the more time you spend with a file, the more you will learn. But what I used to do as a hobby, as a pastime, is I was on a Discord server, and these people would post files, and me and a few other guys. This was like kind of an unspoken thing, but we would try to take the file, get the model out as quick and dirty as we could, and then try to be the first person to post a screenshot of it, just to kind of just kind of as a flex, you know. Like, look what I fucking did, bro. Like I did that in like fucking hour, bro. And it was just kind of a flex. So I would do that anyway, daily, like fucking daily. And I still don't feel that I'm proficient or anything like that. Like I'm not a pro. I just know a few things, and the way the models are stored are so simple that most of the time it's just luck of the draw. You might see something someone doesn't see initially, and that gives you the upper hand on how to get the model quicker, and you get that model out quicker. Okay. And so yeah, I just did that off and on as a hobby. And so my perspective is just how to get the model out as quick as possible and as dirty as possible. That means we're not doing anything cleanly. So that's my perspective, right? But of course, you guys are coming from perspective of importing and exporting. And this is still possible because the file format is actually so simple. So here is the file in the 010 editor, and then you guys sent me, or somebody sent me, a binary template. This binary template actually completely details the file. So here the file is shown in the template where you have access to every block in the file, um, and how that kind of works. That's crazy. I wish I had that a day ago. But anyway, yeah. So if you see what we have here, it's basically the MEF file is basically a folder, and then it has different files in it. And if you think about a file folder that you have in your desktop, then you have different files in it. You have maybe pictures, videos, text files, anything, right? And so that's what's going on here. We have a arrangement of files, and some of them may be related to the models, and some of them may not. We don't know, right? And so it's an exploratory process where you're kind of discovering what each one of these things do, right? So, for example, I can just give you a couple off the top of my head. Mesh just gives you a bunch of numbers, metadata basically. ATT is the attachments that attach the bones. This one I don't know. Actually, in fact, it's empty. Actually, empty, empty, empty. This one, same thing. It just gives you some metadata. This one is the face data. This is the material data. This one is the vertice data. This one is collision related, collision related, collision related, collision related, collision. It's all collision. So we can completely ignore the vision data. And so if we were going to replace the model, you would update the meta here, the face buffer, the materials, and the vertices. Okay, you would just replace those three. It doesn't sound that it's not really that hard. Really, technically, you're just dealing with the faces, the vertices. The materials are going to be affected by that, obviously, because you're going to replace that. And then you're going to have different counts that need to be reinserted into the mesh and DRDR metadata. These store the face and vertex count here as well. So yeah, so in terms of like researching and understanding the file, it is literally like right here. Um, the way the file format is built is actually extremely simple, and I'll explain that and how that works. So if you look at the top here, the first 20 bytes is just the header. Actually, you can just click on here, and it will detail that as well. We have the header, and we have this other code here. But anyway, the first 20 bytes is your header. So we can just kind of discard that. And then after that, we have these different chunks or blocks. And so it's like a stack of blocks. You can think of a stack of cookies. You might have some white vanilla cookies and some black chocolate or brown dark brown chocolate. And you can spot the differences of those different cookies because they're different colors, right? And so this is the same case we have here. We can travel through the file and see what's stacked in here, and we can, if we see a chocolate cookie, we can take it out and taste it. And that's exactly what we're doing here. The way that this is done is they define a 16-byte block header, and this block header explains what is inside this file. Okay. So in this case, the format is explained, of course, in here. It's called header. It consists of a 4-character code, which is the type, and then the size. That's how much data is associated with that block. And then these other things, I'm not sure what they do, but I don't think it's as important. So these 16 bytes are the subheader, and then if there is a non-zero value here, that is how much data that is there. So in this case, if we go back to the inspector here, it says 176 bytes. So in this case, that means after the 16-byte header, we would then read 176 bytes. So if I select 176 here, yeah, you'll notice that it ends just at the next block. And so that's how that works. So we read this one. It says that it has 0 bytes. That's true. There's nothing after that. It's another block. And then we read another block, and another block, and another block, and another block. And so that's how that works. And that's how you traverse or travel through the file. And that's how this is acquired. It just goes from the header, and then it just goes to each one of these blocks. And you can see each one of these blocks. Okay. Then you can expand it, and you can see what the variables inside of each particular value actually means in that block. You can pretend the blocks are actually separate files in this case. I think that's probably okay to say. Anyways, what we're going to do now is just focus on ChatGPT because I think there may be some underutilization of that technology. We're in an era now where we can rely on the large language models to do some of the heavy lifting for us. So we of course just can't be like, do thing for me. I don't understand thing, but do thing. You still need to kind of know how to convey your wants to the AI such that it can assist you in a manner that's, I don't know, it can't, it's like not a mind reader. So you have to be very concise in what you're asking it, and then it can do some automation on writing code and stuff like that. Or if you don't know a particular type of code, you can ask it to interpret it. So we're going to be using ChatGPT to effectively do a really simple model importer on this helmet, just to kind of show the inner workings of that. Now, in terms of the hex editor, I've already looked at the file. I can't reenact my surprise of, oh, I found the faces. Oh my god. That's not going to work. You would have to do a live thing of that, and that'll take like a whole day, so it's not really going to happen. So this is one of these situations where you're going to have to sit down with your own file, try to figure it out, fail at it, and then go to somebody, and then have them explain to you what you fucked up, and then you learn from that experience. That's how I learned. I would go to the website when it was still open, ZenHacks, and be like, I don't know, I fucked up. And then somebody would say, hey, this is how it works. And I would just study how they did it. So a lot of it is just, um, trial and error and just learning from experience, unfortunately. So there's not much more I can say in here unless you don't know how a hex editor works. That's a different problem. If that's the case, then you should further research your hex editor and how to use it via YouTube. I would assume would probably be an adequate source of knowledge. So anyway, let's just jump into ChatGPT and try to get a Blender script from that. All right, so we're going to go into here. We're just going to write up quick outline of what we want it to do. Take note of what this thing does, by the way. This is the interpreter. So it says byte, and it shows a byte. You click on this, it's called a short, and it selects 2 bytes. So these are shorthand, shorthand descriptors or phrases for describing the same thing. So 1 byte, boot byte may equal a character. It may equal well, it might also call it an int 8, for example. 2 bytes might be short. Might be called a word. Might be called obviously it must be called 16. We got 4 bytes. Might be called a long. Might be called a double word. Might be called int 632. It also might be just called a plain int. So for example, here when we click on this one, it selects 4 bytes and it's just called int. Okay. The other thing you understand is there's a signed and unsigned mode, where if it's signed, it can be a negative value, and if it's unsigned, that means it can never be negative. It is only positive. Only positive. So this is negative and positive. This one is only positive. Okay. So those are denoted as well. So if I say like unsigned int, that means it's unsigned. If I say signed int, that's another way of saying it. They might shorthand it and say uint or just int to imply that it's signed. Okay. There's other shorthands with floats as well, as like float equal to a real. Um, this is also equal to 4 bytes, by the way, just encoded differently. All right, so that out of hand. A little bit about C. C will use a thing called a struct, and so the idea is that you have an operator. I don't think it's called an operator. Some sort of keyword. So struct is a keyword, I guess, and it requires a variable name, like I don't know, a header, and then you create these curly braces, and then you can describe what the variable header actually means in the context of the keyword struct, right? So we're gonna use a C-style way of describing this. So we would say that the header consists of it's 20 divided by 4, so it's 5 ints, and then we would describe them. So we have magic, and then we can just get the value here. Okay, copy this. Okay. Yeah, that's fine. I was gonna say that's not proper C, but you know, don't worry about it. The ChatGPT will know enough of how to figure that out for you. These are actually uints, by the way. We'll be a little more concise with that. And we're gonna now describe how the chunks work. And again, that's 16 bytes. I'm gonna make a comment. Comments in C are usually double slashed like that. I'm gonna be a little more concise about this as well. Okay, I was like really specific about that one. Sorry. And then after that, it's the uint size. I keep using these semicolons. Um, only Okay, and then I'm just gonna say these are unknown, so save time there, and then skip. Okay, so I think that was concise enough. Well, we're gonna put this together in a blurb that we're gonna pass in the ChatGTP. So we're gonna say make a Blender import script in Python that imports images. Oh my god, import the faces and vertices into a mesh object into the Blender. See, okay, and here is the file. I'll just copy one of the files that I have here. Helmet's fine. And the structure of this file is as follows. There is a 20-byte header followed are repeating chunks until the end of the file is reached. For the face chunk, divide the size by 6. So now the reason why it's 6, by the way, just explain that. Where's the face data? It's right here. Okay, so if you remember from that example, here, what the heck's going on? We're storing 1, 2, 3 to form a triangle. So if you look here, it's doing 0, 0, so it's using 2 bytes, and so it's 3 times 2, it's 6, so it takes up 6 bytes per triangle face that's defined. I want to say this is fixed. This one I already figured out. I'm not gonna go through my process because it'd be kind of disjointed, but it consists of position. This is normal. This is UV. This is just 2. And I think that's it. Yep. Please complete a Blender program to import the mesh from these to a scene object. Alright, I think that's pretty good. I think that's quite detailed. Didn't mean to save that. We're going to move this into here. Okay, so I have, this is ChatGPT 4.0 mini, so it should be quick. They got rid of ChatGPT 3. I don't know where they sneakily deleted it. This is all I got here. So we're going to use this, run that, and then over here I got Blender. We got the script open. I then activated the toggle for the system console, which is down here, so that we can run the code and see the export at the bottom here. Oh, that was interesting. It like straight up crashed. So what we're gonna do is we can try again, or we can try with we can try O1 mini. Sure. Okay, so it says here. For ND. This weird. This looks like it's kind of messed up. I think I forgot to include a thing. Um, okay. Each chunk, if chunk, the ending position needs to be aligned to the next alignment of 4. So in the case of the faces, the block is at the correct position, causing off and alright, this is a little hard to explain, but there's two values in there. There's the size of the data, and then there's the chunk size. The chunk size would then bring you to the correct ending position of your block. So technically, I should be using that one. But I'm just explaining that if it just skips to the next multiple alignment of 4, then it's the same thing as the chunk size. Um, it's a little bit convoluted, but anyway, we'll try that. Okay, so now it says, oh, you can't see this. It's over here. So it says that successfully imported the map. Okay, there we go. So just see what we got. Oh, what the shit? There we go. Oh, it's a helmet. Oh my god. Who's this beautiful motherfucker? We'll just expand that. It's a little bit too large. I'll switch this into just normal mini. No, that was normal mini the whole time. I thought it was on O1. Can you scale the scan? God, I must have brain damage. The mesh 0.01, please. Alright, I'll just expand that and then we'll just see the model. There we go. Well, the cube is the default cube, but it's not involved with it. Yeah, we didn't really include the texture coordinates or the normals. So how about we ask it to include that as well. Can you also apply vertex normals and UVs? Okay, give me some weird error. Oh, okay. The vertices, I guess the physical vertices, I guess. So apparently it just made up its own faces. That seems kind of stupid, but yeah. Anyway, so now I've explained that, and hopefully it works now. Yeah, it's still not. Wait, is it still importing the damn thing? Yeah, we'll switch to O1 Mini for a second. Right? I think it was O1 Mini. Maybe it wasn't. The code seems to be shorter, which is kind of strange. Oh yeah. I don't think the normals are applied because it still looks kind of rough. Yeah, there's still some problems going on here. Not sure what's up with that. I mean, they seem to be there, but that's weird. I'm not sure why they're working. They're not. They're not working. But let's go back to this. Not sculpting. Scripting. We can review the code, I suppose. So we have we're doing custom import. It sets the arrays at the beginning. Reads the header. Comes down here, reads a chunk. It's looking for the chunk face. Looks like it captures it. Divides by 6. Um, Down here in the vertices, it looks like it's reading. I'm not really sure what's going on with this representation. It looks a little bit complex. Okay, so it's reading that. It's copying it from the buffer. This looks correct. So we're getting those 3 components. So it says vertices, normals, UVs. Huh. It looks like it's correct. I'm actually not really quite sure why it's corrupted looking. Um, hmm, that's weird. It might be the faces. Something wrong with the faces or something. I don't see a bad face here, but yeah, something's going on there. I don't know. I don't feel like figuring it out. I'm tired. I'm tired. Okay, but yeah, you can see how easy that was. Just using ChatGPT to generate code. You don't necessarily need to know Python. I don't. But I know enough to kind of get myself right around the logic, right? So, like, you'd have to at least learn some programming at least to kind of understand what's going on. Like we're importing these dependencies, and then here we're defining functions, and these functions can then be called within other functions. And then you have some logic statements, which are like if this and that kind of thing. So here it's checking the file. Here it's basically assigning or initializing these variables to receive a list of values. Try means that it's trying to catch any errors. Um, with open just means that while this file is open, it's going to do the stuff in here. You just get a better idea of it as you look at more code. And then, of course, you can ask ChatGPT what a part of code does, and it will expand on it. Or you can ask it to make the code more simpler to read, and it will recode it in a way that's simpler to read. So hopefully that kind of represents, oh, what's this thing? Oh, UV map. It still doesn't look great. It looks like it recalculated it right here. That actually killed the normals. What the heck? still looks like trash. I don't know what's going on. This is getting on my nerves. Like, what the heck? I don't know, I'm kind of tired. I forgot what I was saying, but thank you for watching. um, I don't know how insightful that is, but that's hopefully kind of inspires those that are just starting that it's not actually that hard, with ChatGPT. It helps do programming. It's not going to make your program entirely for you. As you can tell, it makes little mistakes. And there's just a huge emphasis on just gaining experience. Excuse me. And in actuality, you're just finding those two things, the vertices and the faces, and you just slap them together. Um, One thing I will do though is I'll show you what it looks like when you swap these things. So let's see, we'll swap a couple things here. Okay, I'm gonna swap the normals. Don't want to save anything. We're gonna delete this guy. I'm gonna run this guy again. Wait, where is it? Ah, there it is. So this is what the normals are gonna look like. So the vertex normals are a direction. So that I believe they're normalized. So because they're normalized, they're between 0 and 1, where I think in this case negative zero point 0.5 and plus zero point 0.5, and so it fits within a 1 space. And because they're pointing in different directions, these tend to visualize themselves as a ball. So if you import a set of x, y, z coordinates and you're trying to fish around to figure out what these things are, and you import it and it makes a ball, well, that's going to be something like normals or binormals or tangents, whatever. But yeah, these are normals, what they would look like. And then UVs would also have a distinct look to them as well. Oh, I should have deleted the other one. There is something seriously going on with the UVs. Like, this is normal. Like, why is this down here? It's very strange. It's very strange. I'm gonna delete this. Yeah, goodbye. Oh shit, I forgot that Blender does that. Whatever. Yeah, that kind of looks like stuff. You can, oops, I didn't know this happened. Okay. So you can see some structures here that are flattened, and this is probably correct. That weirdness is probably normal. Anyways, yeah, so that you would see this and you would be like, that's weird. I wonder why it looks like that. And that's because it's texture coordinates. So basically, when you're looking at vertex data and you don't know what's what, you just kind of import it and you kind of explore. But usually it's always the same order. It's always position, normal, tangents, and then it goes into weight data, and then it kind of changes a bit if it's either UV coordinates or if it's weight data. Anyways, yeah, thanks for watching, and hope you have a good night.